My name is Muhammad Azra Arif bin Muhammad Zalman, and my matric number is 201030. Today, we will explain about flight control and management. Aircraft flight control are the means by which a pilot controls the direction and attitude of an aircraft in flight. Flight control systems are subdivided into what are referred to as primary and secondary flight control. Primary flight control are required to safety control an aircraft during flight and consist of aileron, elevator, and rudder. Secondary flight control are intended to improve the aircraft performance characteristic or to relieve excessive control loading and consist of high lift device such as a slat and flap as well as flight spoiler and trim system. Movement of any of the primary flight control cause the aircraft to rotate around the axis of rotation associated with the control surface. The aileron control motion around the longitudinal axis. The elevator control rotation around the lateral axis, and the rudder control movement around the vertical axis. The most basic control system are mechanical and auto. They date back to the earliest aircraft type, in use in the majority of flight. General aviation aircraft. In this design, a collection of mechanical components such as cable, pulley, rod, and chain transmit the movement of the flight deck control to the appropriate control surface. In a larger and faster aircraft, the aerodynamic force become too great for pilot to overcome without assistance, so hydraulic systems are often incorporated to move the flight control surface. In some newer aircraft models, the case for reduced weight and associated fuel saving has led designers to replace most of mechanical components with computer and fiber optic produce control system, which are referred to as fly-by-wire. Next, about the flight control, the highest level of automatic flight system is the flight control system. Companies flying aircraft for hire have special results they wish to achieve. Each flight of an aircraft has vertical, horizontal, and navigational components which maintained by manipulating the engine and aircraft airframe control. While doing so, numerous options are available to the pilot. The FMC has stored in database literally hundreds of flight plans with three-dimensional operational parameters that can be selected and implemented. Okay. Next.
For the history of flight control and management history.
Okay. Nama.
Okay, sorry. My name is Ilham Shauki Bechare. My matric number is 20073. For flight control and management history, for flight control, aircraft control system have evolved exponentially within the last 100 years. The first generation of aircraft held the pioneering technologies that initiated the pace towards control systems that are now characterized by increasing sophistication and ingenuity. The new demands for speed, especially during the Cold War era following achieving the dream of breaking the sound barrier, have placed a considerable pressure on aircraft designers to come up with more robust and better responsive aircraft flight control method. Although the basic principle of pulley and rods to control flight surface survived throughout the second generation of aircraft in World War II, as well as continuing with some of the third generation of aircraft. The disadvantage of inefficient system will mark its end by the fourth generation, with the development of fly-by-wire system. Hydromechanical actuation was incorporated in the second and third generation of aircraft. Although this also was later replaced in the fourth generation by electrical hydromechanical control. Following the fly-by-wire age that dominated the aerospace industry for the last 30 years, the current fifth generation of aircraft are moving more towards fiber control optical system with more pure electrical actuation, replacing the heavy copper of the previous system as well as reducing the harm of hydrofluids. The environment while it's also reducing the total weight of the aircraft. The purpose of this report is to review the journey of aircraft control systems as they have evolved through this generation. For flight management, in 1978, Honeywell began developing its flight management system, putting the first FMS into service as standard equipment in 1982 of Boeing B757 and B767. Now, every major aircraft manufacturer includes a Honeywell FMS in their cockpit. In total, Honeywell FMS has 15 distinct baselines flying on more than 14,000 aircraft. It currently totals around 1 million source NOC and increase perhaps 2% per year. R&D is already underway for innovation and improvement to both new and existing technologies. For example, for the trajectories, future and navigation system require time of arrival and trajectory-based optimization. Next.
My name is Muhammad Adarukman bin Husni and my metric number is 200596. So I will explain about the work principle. So as Azrael said earlier, the flight control are divided into two, which is primary and secondary. So the main work of this flight control is it automatically control the aircraft where in hazard or failure condition. So when something happen and the pilot can control the aircraft, the flight control will undertake it. So uh, what is primary flight control? Primary flight control is basically uh, working on the safety control and aircraft during flight and consists of ailerons, elevators, or in some installations. And the secondary flight control is include flight control, ground, spoiler, and trimming. Flight control is affected by multiple flight sections located at 2/3 of the wing trailing edge inboard. So I will add some information about autopilot work. And autopilot work require input information to control an aircraft motion. It is true that when the autopilot activate, it will go through the path and have been set up. However, the presence of wind can change the direction of flight when it flying. Hence, gyros, which are used to sense motion while an altimeter sense altitude, will stabilize the aircraft. So the most capable autopilots can actually land on aircraft, control engine power, and manipulate all 6 degrees of freedoms. So autopilot is very near to the flight control and flight management works. These three are related. So moving on, I will explain about flight management work. So flight management work is when it will provide latitude and longitude of aircraft position to autopilot. So when it recognize the latitude, it will send the information to the autopilot, and autopilot after that will that will conduct the aircraft. So uh, flight management system are most correlated with the autopilot working on. As I mentioned earlier, this is because flight management will update the latitude and longitude. Besides, the desired course was set by entering waypoint information, and deviation from the selected course was provided to the autopilot. This development lead to integration of the autopilot and the long distance navigation computer into one unit, and later the the flight management usually working on by controlling the aircraft and the navigation equipment, as it contains a variety of database for airport and radio aids. So next.
Name is Faiz bin Hasnul Hafiz. Mathematic number is 200.9. So, what is application of this topic? So, as Adam mentioned earlier, this is application of the easiest application of flight management is auto flight system and automatic takeoff and landing. So, under auto flight system, the research and I'm gonna elaborate about research and production of manned and unmanned aircraft powered by improved value and ability of automated flight control, single flexible and configurable device offering the required functionables with assured reliability, accuracy, and robustness for a broad variety of automated flight control system, configuration of fixed wing aircraft and sensor environment, use of benefit of model-based system and software development and strategic partnership to reach and go beyond the state-of-the-art digital flight control of the CS-23. So under automatic takeoff and landing, I'm going to elaborate about manned and unmanned automatic takeoff and landing, consideration of disturbance, technical errors, and robustness in design and operation, stochastic investigation of system performance, and model-based requirement of engineering, safety and certification related development. So about the autopilot system, it is also called as auto flight system. So there are many research from production and manned and unmanned aircraft. So there are new material that are inexpensive, durable, and good quality. So the research made to be lightweight, so it is more affordable, and for ATOL, that is automatic takeoff and landing. I'm going to highlight about most difficult high flight operating procedure for fixed aircraft. Failure or vibration may quickly contribute to irregular ground interaction. So, so the most crucial part is takeoff and landing. So it is required for automatic and not manned So there is unmanned takeoff and landing. So that is all. Next.
Hello, my name is Muhammad Taufik Azizi bin Azman and my metric number is 2000802. Based on this report, our group would like to conclude that the SC was serviceable at takeoff and was operated within the approved limitation. Thus, the crew members held appropriate licenses and were qualified for this flight. There was no indication of specific concerns about the flight or any tension between the crew members. So moving on to the recommendation, there are three aspects that our group would like to recommend. The first one is between manufacturer and operator. The joint effort should be made to minimize MEL, TDL, DDL allowance to avoid lowering safety standards by overloading pilots and ensure that whenever found necessary to maintain such item, very clear procedure addressing pilots and maintenance crew to be made available. Clear engagement status indication for the autopilot should be made available to the crew to avoid any possibility of incorrect perception of ambiguity. The next aspect is Civil Aviation Authority. We would like to recommend that to ensure that all operators strictly adhere to CAA regulation and requirement, especially in remote station. The third aspect is from pilot training. It should emphasize the pilot training as early detection and recognition of condition that could lead to upset condition and timely recovery action from upset condition to counteract sudden unknown abnormal condition. The last aspect that we would like to recommend is human factor. And we would like to suggest that in-depth studies of the spatial disorientation, ways of early recognition between crew members and appropriate crew action to overcome it and increase crew awareness of the phenomena. Although a level of CRM was observed, it is clear that more emphasis in this area of training will achieve earlier recognition and recovery from abnormal condition. That's all from us. We were from the group 8. Thank you.